So, multiplying, dividing, I'm going to go ahead and write a statement down here. And you guys will write it in your notes. So when you multiply and divide, you get a product. And you're going to have to write that answer down. When I use the number sign, it just shortens it up so I don't have to write number down, so I'll do that quite a bit. So sig figs is a way to shorten up significant digits. They're interchangeable. Significant digits, significant figures, they're interchangeable. Okay, so we just are going to apply this statement to every time we multiply and divide. So the product in your answer will have the exact same number of sig figs as the measurement that you're using to multiply and divide, or the measurements that you're using to multiply and divide, with the least number of sig figs. Okay, so we've these on the board. Since I'm recording this for people who will be gone, I'm going to go ahead and rewrite that. These two on the overhead, and so we'll look at these two and apply that rule. Okay. In fact, I'm just going to do it off the side here. Don't write on this side because I'm going to use this side since it's directly proportional to the other side. And we're going to go ahead. Now these don't have units. I don't want to confuse you with putting units in yet, but eventually all of these will have units in there. Okay? Oh, I don't know why that does that. But that's okay. So this is what I want you to do. I want you to apply this rule before we even do any problems and see what kind of answer you get out. So I want you to do 1 and 2, and then I want you to give me an answer. And believe it or not, these problems we're doing right here today, they are what caused students on the first chapter test, chapter 1 and 2 test, we'll combine them, to get a lower grade. What we're doing today is the most commonly missed problems on the test. And the reason why is you have to be exact. You have to give me the exact answer, not, approximate answer, the exact answer it's supposed to be. And so students will mess up on these two types of problems, the adding, subtracting, multiplying, dividing. So I say that to you now to just kind of let you realize that that process that we have for you to be able to do on the test and be successful for the remaining of the year when we do labs is to go through that process. So, all right. So write down your answers for that, for those two. So the first one says we need to look at our measurements, and we need to look at the one with the least number of sig figs, and then we need to apply that to our answer that we have. So this this first one, the answer that you come up on your calculator will not give you 2. So you have to do some rounding to get that. Okay? So you have to limit it to 2. If you didn't limit it to 2, if you look at your answer and you count the significant digits and there's not 2 there, you've done it wrong. Because according to that, we need to limit it to 2. So this would be 12.64. But that's 4 digits, right? If I say 12.6, how many digits is that? 3. Ah, got it? I'm going to fix that. Okay? So then what should it be? 13. 13 should be my answer. Does that make sense? How many digits are in 13? 2. How much is in 12.6? 3. That's not the lowest number of significant digits in my measurements. It has to be 2. Definitely is not 12.64 because that's not even one of the choices. Okay? Questions?
So when we do this, do we only, like, for the answer, do we just give you 13?
Yep.
So we don't have to put 12, like, would that, what we actually...
No. Sometimes it's good to write down what's on the calculator, and then you analyze that, and then you look at which of those digits are important and how am I going to round it. Because I think sometimes students will do this, and they'll just, off their calculator, they'll write the answer. Well, if you have it written down, you can realize that these 2 digits here, those 2 places, not those 2 digits, but those 2 places have to be shown. You can't show any more than those 2 places. So that 6 has to round up. Yeah.
So we can use calculators in here?
You bet. We're not going to slow up the process of you guys learning based upon you just doing it by hand. It's important to do by hand, but the main idea in chemistry, I'm not concerned about that. Okay? So the next one we've got 4, right? And we've got 3. So we need to limit our answer to how many? 3. So then when I write my answer out, okay, then I might write it out and then look at it to see which 3 do I have to write down. Hope I don't get another line here. Okay, so on my calculator, that's what I got. So let me tell you why students will get this wrong, because they'll count this as one of the 3 they have to write down. They'll count the 0.0 as one of the 3 that is significant. It is not significant. I don't know how many times on labs, as the year goes on, students will count that 0 as one of the 3 that's significant. It's not significant. Why? What's the rule? It's what? Leading. Okay? Leading the pack. So I can't count that. So the ones I have to count is not that one, but I got to count these 3. So if I got to count those 3, I've got to look at the last digit, and I got to see the one I'm not showing, which would be the 4th digit, still has a play in a rounding process. So sometimes students will get this wrong because they'll write an answer of 0.0589, and that's not right. That's not as accurate as it could be. Because what they're saying is that past that 9, there's a 4, 3, 2, 1, or 0 that's in that next spot. That's not the case. There is an 8 in the next spot. So what does that 8 do to the 9? It makes it 10, which makes it 0. Which then, that 10 rounds the 8 up to 9. And so the correct answer for that would be 0.0590. You have to write the 0. Because if I write 0.059, how many significant digits is that? .059. If I just wrote .059, how many significant digits is that? 2. I got to write 3. So I'm giving you some tough ones today. Okay, I'm not going to give you easy ones to do, and then when you get a tough one, you're like, well, we didn't get one like that. We never did one like that. So I'm doing ones that are tougher. That would be a tougher one. I would say on the test, a third of the students get that one wrong. Okay, it's just paying attention to detail. All right, and if you have to write it out, underlines the one that are significant. That might help you go, okay, I need to include those 3, okay, but this one I don't include. How does that affect the last digit? Does it round it up? And then if I round it up, does that cause the other one to round up? All right. So you guys in here can write these 3 problems down and then do them. And do the calculation. Now, if this was a test or a quiz, you have to be spot on. You can't have any digit different than what I show you. Okay? So write those 3 down, if you would. And if you count this as 4 digits, that's wrong too. Because the zero's leading there, and there's only 3 digits in that one. So when you divide that out, you get an answer of 23,648.6. How many digits can I show? 2. I can only show these first 2. And what's the rest of the number become after those 2? Zeros. I cannot believe on tests, I get an answer for this one, and they'll write 23. That'll be their answer. Like, okay, how does 23,648.6 become 23? It becomes 20, not 3, but 20 what? 4,000, right? Because that 6 rounds that 3 up. So if it's 5 or above, you're going to round it. So 24,000. Okay? All right. The next one. We come up with an answer for the next one that is 0.02481. That's on my calculator. How many can I use on that? There's 4 here and 2 here. So I can only show 2 in my answer. A lot of times on this one, I'll get an answer that's 0.02. What are they doing wrong? They're counting the 0 in front as significant. It's not. It's a placeholder. So that would be 0.02. Now, does that 4 stay a 4 or does it go to a 5? 5. 0.025. That's it. That is it. Okay? And the next one, we're going to start using scientific notation. I'm going to introduce to it on this one. A lot of times when we get numbers where we got a lot of zeros in front or behind the decimal, we won't want to do it that way. Okay? So on that one, I'm going to use 3 is in this one, 2 is in this one, so 2 in my answer. All those zeros in front don't count. So it would be 0.0, and then the next 2 count. So these 2 count. So it'd be what, 1/6, right? And that would be your answer. Okay? Any questions you got on that? Okay. I know it's being picky, but that's the way it is. Okay? So then, real quick, we're going to look at the other side. The other side doesn't need maybe as much of a explanation, but the other side looks at accuracy of the measurement. It really doesn't maybe necessarily count significant digits, but it looks at the accuracy of the measurement. So I'm going to go ahead and write down the statement associated with this rule for adding and subtraction. So this one says the sum of the answer has to have the same accuracy. Now, I'm not using significant figures on the right side. Left side, I'm using sig figs. The right side, I'm looking at accuracy. So, what determines the accuracy of a measurement? Oh, the placement of the decimals associated, placement of the numbers associated with the decimal. Okay? That's what determines what it's going to be. So, once you guys have that written down, I'm going to give you 2 examples. And then I'm going to give you an assignment for tomorrow that you're going to have to do. And it's real simple because most of them you given answers for. Alright? So, everybody got that written down? Because I'm going to go ahead and erase this side over here so I can put the information in to do. Okay.
Mr. Garland, what do you mean, like, the accuracy?
Okay, that's what I'm going to talk to you about now. Okay? So, I've got a 4.05, and this will make sense once we do 2 examples. Okay? So, let's say that we're adding some weights together, and we want to come up with a final answer. If you look at those 3, which of those 3 is the least accurate measurement? 2.3, right? Does everybody agree that 2.3 only goes one place to the right and the other ones go 2 places to the right? So my answer, how far can it go to the right of the decimal?
2.3?
1 place, right? Does that make sense? I'm not counting. If you guys start counting significant digits on these, which students will do, so your answer you're going to come up on your calculator is going to be 8. Is that right? What should it be?
8.0.
8.0, very good. Okay? Your lineup of your answers should be lined up with the least accurate of those measurements. So that's what I mean by that accuracy. That's about the only way I can write it because I can't use significant figures because then you guys will think that we're counting those. Okay? So the last one we'll do, this one's a tough one. So 1500, 15,000 plus 762 plus 95. If you can get this one, you've got this ruled down. So it's 15,000 plus 762 plus 95. Do that, then write what you think the answer is supposed to be according to the least accurate of your measurements there. Students get these 2 switched up. The multiplying, dividing, adding, subtracting. Students get that messed up. So, of those 3, which one's least accurate?
None of them?
What's that?
None of them?
Okay, so this one goes to the 1 spot. This one goes to the 1 spot. What does this one go to? The 1,000 spot, right? Because these are rounded. Okay? So, your answer for that one And then let me give you the assignment here real quick.
So what's the answer?
The answer for that one, is 16,000, because I think it's 15,857, right? So it's 15,857. So then I have to limit my answer to this spot, because it's the least accurate, because those zeros are not measured. So it'd be 16,000 would be your answer. Okay, so your assignment is page 35, and it's 17 and 18, and it's also page 39, 31A through D, and 33. And this is in your book. So page 35, 17 and 18, and then page 39, 31A through D. If you notice, there's 3 of the 4 are odds. So work on those. Okay, sorry it took a little longer, but Wednesdays are that way sometimes. We'll see you tomorrow. Have that done.